Bismillahirrahmanirrahim. Assalamualaikum. Good afternoon for the all audience or participant in this room. Welcome to the Rado Institute. For this time, we will try to discuss about how to using the Bayesian Markov chain Monte Carlo to estimate the parameter of the new models created by Rado Institute, namely alpha power, generalized inverse power Rado Institute distribution. This model have the 4 parameters. Okay. Our discussion today based on the one research article. Okay, this research article. The research article with the title Alpha Power Inverted Exponentiated Weibull Distribution with Data Application, published on the Journal of the Mathematics and Statistics in the 2024. In this research article, especially in the equation 6, we can find the concept of the alpha power transformation. The alpha power transformation is mean we try to produce the new models, new probability models, with the give one more parameter alpha. Okay. In the sixth equation, there is the density function. It's meant for the order density function, and we have the cumulative distribution function for the letter of the fx. So for these times, we will try to using the small fx or the density function with the density function. We call that generalized inverse powers Rado Institute distribution, like in this one. This is the density model of the generalized inverse power Rado Institute distribution with the 3 parameter alpha, theta, and beta. For the fixed information or the complete information about the generalized inverse power Rado Institute distribution, you can come to www.radoinstitute.com. Okay, in this density function, we have the concept of the upper incomplete gamma. K is mean the number of mixture gamma density function. Okay, so this is the fx or the density function. And then based on this the candidate books, we have the cumulative. This one of the cumulative. Okay, the cumulative. This is the upper incomplete gamma. K is mean the number of the mixture density and beta is a parameter. Okay, based on this cumulative and based on this density function, we can use a 2 function for the create the new models, namely alpha power generalized inverse power Rado Institute distribution based on the equation 6. With the density function, we try to using the density function of the generalized inverse power Rado Institute distribution, and we use the letter of fx or the cumulative by using the cumulative generalized inverse power Rado Institute distribution. Okay. Based on this research article, especially in the table 6, we have the 2 set data. Okay, based on the table 6, we have the second, they give the 2 data, the first and the second data. For this time, we will try to using the second data. We try to using the R to estimate the parameter of the alpha power generalized inverse power Rado Institute distribution. Okay, open our R. Is one. This is the second data set. We run our second data set. Okay, we check our data. That's one. Okay. So for the case of the Bayesian Mcmc, of course, we must, the first time we will create the likelihood of the alpha powers generalized inverse power Rado Institute distribution, like in the blue one. Especially this one on the blue one is the density function of the alpha power generalized inverse power Rado Institute distribution with the 4 parameters. The first parameter TA, the second parameter E, the third parameter U, and the T is the fourth parameter. Okay, so we run the likelihood function. This is likelihood function. We run likelihood function. After we run likelihood function, we try to create the coding of the Markov chain Monte Carlo. For this case, we will try to burning in the 10,000 times with the initial value. This one initial value, 1 for the parameter 1, 15 for the parameter 2, and 0.2 for the parameter 3, and 100 for the parameter 4. Okay, the first parameter of U, this is the second parameter. This one is E parameter, the TA, fourth parameter. W new, it means the error for the parameter new. WT, the error of the parameter T, and WE, the error of the parameter E, and WTA, the error of the parameter TA. So we have now the Bayesian MCMC based on the posterior. We can find the posterior by the formula, the likelihood function, the multiple by prior. We use the non-informative prior on this case. Okay, because we have the 4 parameter, so we have the 4 for the posterior density coding. This one for the parameter new, this one for the parameter T, this one for the parameter E, and this one for the parameter TA. Okay. In this case, we are not directly run this program because we have run before. Because we know that if we are discuss about the Bayesian MCMC, of course, we need the several time to run the program. So that why we have runs before. For this time, we will only discuss about the result, especially for the trace plot and the posterior plot. Okay, like this one. We run the trace plot and the posterior density plot. Okay, this one, we have the 3, okay, we have the 4 parameters. This omega parameters, theta parameters, beta parameters, alpha parameter trace plot. So all trace plot like is convergent. Okay, based on the posterior density plot, we will try to find the parameters. We will try to using the median of this parameter. Okay, because we know we have the 4 parameter. For the each parameter, we will have the 10,000 parameter. Because we burning until 10,000 times, automatically it means for the each parameter, we have the 10,000 parameter. So to the representative by the ones parameter, we just using the median of the Bayesian. We try only using the median value. Okay, the median value. Okay, for example, for the omega parameter or the first parameter, we using the median of U. The theta or the second parameter, we using median T. Beta for the third parameter, we using the median E. And the alpha, the fourth parameter, we are using the median TA. We run our program. Okay, run a program. So after that, we can check here. What is the first parameter or omega? And then the theta for the second parameter, on the beta for the third parameter, and the alpha for the fourth parameter. This is parameter. So we will try to using the parameter to check the density plot and then the cumulative plots. XE is mean we will try to using for the density plot. XX we try to using the cumulative plot. And this one is the theoretical of cumulative. This one of the density of the alpha power generalized inverse power Rado Institute distribution. Is the long function here. You can check in the blue one. In the blue one, it means the density function of the alpha power. Generalized Inverse Power Rado Institute Distribution. And for this one, this is cumulative of the alpha power Generalized Inverse Power Rado Institute Distribution. We will try to using the density plot to capture histogram data by the density, and cumulative, we will try to capture of the cumulative theoretical by the cumulative model. So we run our program, our coding program, and then we check the density plot like this one and the cumulative plot. Okay, based on this two plot, we can see we have the goods parameters by using the Bayesian Mcmc. In the blue lines for the PDF plot or the density plot, the nice plot or the nice curve or the nice density function curve to capture the histogram data. And then the next plot, we can find the blue plot can nice capture the gray plot. The gray plot is mean the theoretical of the cumulative, and the blue one is the cumulative of the alpha powers Generalized Inverse Power Rado Institute Distribution. So for this time, once more time, Rado Institute have success to create the new models. Normally, the models alpha powers Generalized Inverse Power Rado Institute Distribution. So it means we must always to read the papers, the papers that published on the research article. We always read, we check, and we can find the chance. We can find the chance to create the new model one based on the information from the model that we read on the some research article. Okay, I think for this time is nice discussion. See you again, Rado Institute and Rado Yendra. Assalamualaikum warahmatullahi wabarakatuh.